This software has a main interface, recipes, and calibration. The calibration function may not be used often. If there is any offset issue, we calibrate it before shipment. The most commonly used calibration is the laser position. If the laser engraving is offset, we adjust the calibration position. For example, I place the QR code at position A, but the actual engraving position is offset. Click to place it at the specified position, then a crosshair appears. Click to engrave the crosshairs. The working head starts engraving the crosshairs. The light is too bright to see the actual content. Dim the light source and you will see the actual crosshairs. Let me demonstrate it again. Then click to engrave the crosshairs. This is correct. If it looks like this, then there is an offset problem. We just need to move it until it overlaps. Then click calibration to finish. This is the laser position calibration method. Now, let's start learning how to create a program. When we receive a new PCB board, first, we need to adjust the PCB rail width. We need to know the PCB length and width. Click here. If the PCB width matches the rail width, no adjustment is needed. This option narrows the rail width. This option widens the rail width. The PCB width is 200, so we enter 200 and click Debug. We do not set this calibration unless there is a machine issue. Next, we create the template content to be engraved. Click the target engraving position. Click Move and select the target position. Then click the barcode template. This is where you edit the template content. Click the QR code and select the center position. Then select the QR code type. The first type is data matrix. The other type is QR code. These two types of codes are commonly used. Select the QR code and move it to the center. This is just a quick introduction. These are the two commonly used codes: data matrix and QR code. Let's assume we engrave a QR code. QR codes are commonly used on mobile phones, such as payment codes. After selecting the code type, enter the engraving size of the QR code. For example, a 4x4 QR code. Click Confirm and the QR code becomes smaller. The unit is millimeters. Click Fill to fill the QR code. This machine uses UV laser engraving. Select these options. For different code types, we mainly adjust two parameters. This controls the filling lines. It means a denser engraving process. Click here. Since it is engraved on white soldering mask, we select standard mode. If none of the three modes are selected, it is standard mode. These are the different mode selections. This QR code can be composed of dots, circles, or rectangles. Zoom in to see the differences. If none are selected, it is standard mode. That means it is composed of lines. Click this option. This controls the number of fill lines within a closed area. The smaller the value, the more fill lines. Set it to 0.02. The number of lines increases. The machine speed will become slower. This parameter controls the fill density. Normally, we use around 0.04. We mainly adjust these two parameters. One is the line type, the other is the filling mode. If you want to reduce the filled closed areas, adjust this parameter to shrink the closed area. Set it to 0.01 and the unfilled white area becomes larger. Check the parameters we have set. Next step, set the custom content. Set the content according to the customer's SOP. Assume it is fixed text. I will enter it randomly. This is a fixed 6-digit value. Then add years, months, and days. Select the corresponding format. Assuming the year is to digits, or the year is for digits. For example, 2025, month is to digits, and day is to digits. After selection, it follows the system time. This is the fixed text, then comes the date. Then add a serial number. This is the sequence number. Set the sequence number to 5 digits. Only the last 5 digits change. You can select the data type. Choose the format you need. For example, decimal, which means 1 to 10, 11 to 20. You can test different types. The most commonly used is decimal. Now the QR code rule content is completed. Next step, set the parameters. For white soldering mask, set it to about 1000. With other parameters unchanged, slower speed gives clearer engraving. This refers to the engraving depth on the PCB. We did not change the speed. Changing speed affects production line speed. We control depth through frequency and pulse width. Power and current do not need to be set. The current is fixed. Power is mainly for CO2 lasers. Since this machine is UV, this parameter is not used. Remember these two parameters. Their product must be less than 990. For example, if the frequency is set to 50, then pulse width equals 990 divided by 50. The pulse width will be around 19. The product of these two parameters must be less than 990. If it exceeds 990, the UV laser may not work. So we need to set the parameters lower. Within this rule, how do we set clarity? For engraving on white solder masks, the common frequency is 20-30. For example, set the frequency to 25. The larger the pulse width, the longer the engraving time. Longer time results in clearer engraving. For example, set it to 10. Select the QR code, then click Minimize window. Click the back option to minimize as well. Click Move and select the target position. Lift the PCB. Click the QR code and place it at the specified position. Then click Engrave. The working head starts engraving. Let's check the actual results. Assume this QR code is not clear enough. We set it to 14. The larger the value, the deeper the engraving. We re-engraved a QR code. This one is much clearer. Now we set the parameters to 20. Click the blank area to minimize the window. Compare the difference between the first and third. This is the difference in engraving depth. The product of these two parameters must be less than 990. If the frequency is set to low, the display effect will be poor. Test it again. Low frequency and slow speed cause no issues. If the frequency is high, the display effect is better. Mainly adjust these two parameters. You can try different parameter combinations.